Ammonia. Joseph Priestley first obtained ammonia by heating a mixture of calcium hydroxide and ammonium chloride, sal ammonia. He collected the gas over mercury and named it alkaline air on account of its basic nature. In 1800, Humphrey Davy proved ammonia to be a compound consisting of elements nitrogen and hydrogen. Occurrence of ammonia. Ammonia occurs in the free and chemically combined states. In the free state, ammonia is released during putrefaction of plants, animals, and waste of animals. Hence, urinals and stables often smell of ammonia. In the combined state, ammonia occurs as ammonium salts. NH4Cl, NH4 twice, SO4, near volcano regions. Industrial preparation of ammonia. Ammonia is industrially prepared by Haber process. In this process, ammonia is prepared by compressing hydrogen and nitrogen. Pure hydrogen and nitrogen is sent to the compression chamber. The mixture of nitrogen and hydrogen is compressed to 200 to 1000 atmosphere and sent to catalyst chamber. Catalyst chamber is heated to 450 degrees Celsius. Nitrogen and hydrogen combines to form ammonia in the presence of a catalyst, iron, and molybdenum as promoter. The ammonia formed is circulated through the cooling chamber and it liquefies. The unreacted gas is sent to the compressor again and the process is repeated. Laboratory preparation of ammonia. Ammonia can be prepared in the laboratory by treating ammonium salt with any alkali or metal nitride with water. The saturated solution of ammonia in water is liquor ammonia, and ammonia in the liquid form is liquid ammonia. Alkali plus ammonium salt. Dry ammonium chloride and slaked lime, ratio 1:2 by weight, is heated in a round bottom flask. The flask is kept in an inclined position so that any water formed during the reaction does not trickle back into the hot flask and cause it to crack. The ammonia gas evolved is passed through a tower packed with quicklime, CaO, which acts as the drying agent. 2NH4Cl, ammonium chloride, reacts with calcium hydroxide, CaOH twice, giving CaCl2, calcium chloride, 2H2O, water, and 2NH3, ammonia. Collection of ammonia. Ammonia is collected by the downward displacement of air. Since it is lighter than air, it is highly soluble in water and hence cannot be over water. Points to note. A higher ratio by weight of the alkali is used to counteract any loss of ammonium chloride due to sublimation. Slaked lime is used as it is not deliquescent like sodium hydroxide and potassium hydroxide. Quicklime is used as drying agent since it is basic and does not react with ammonia, which is also basic in nature. Preparation of aqueous solution of ammonia. Ammonia gas is dissolved in water using a funnel arrangement. When the gas is dissolved in water, a partial vacuum is created in the funnel and water rushes into the funnel. Due to back section, the funnel is raised. The rim of the funnel loses contact with the water surface and the outside air rushes in through the gap. The water level falls and the funnel drops back to original position. Preparation of aqueous solution of ammonia. Ammonia gas is dissolved in water using a funnel arrangement. When the gas is dissolved in water, a partial vacuum is created in the funnel and water rushes into the funnel. Due to back section, the funnel is raised. The rim of the funnel loses contact with the water surface and the outside air rushes in through the gap. The water level falls and the funnel drops back to original position. Physical properties of ammonia. Ammonia has bitter taste like that of a soap. It is lighter than air and is highly soluble in water. The physical properties of ammonia are listed below. Nature: colorless, strong pungent smell, slightly alkaline. Physiological action: affects tear glands and respiratory muscles. It is fatal if inhaled in large quantities. Liquefaction: ammonia can be liquefied easily at low temperatures. Boiling point of liquid ammonia is minus 33.5 degrees Celsius. Freezing point of liquid ammonia is minus 77.7 degrees Celsius. Solubility: ammonia is highly soluble in water. 1 liter of water dissolves 702 liters of ammonia at room temperature and about 1200 liters at 0 degrees Celsius. Dry ammonia is filled in an inverted round bottom flask which is closed with an airtight cork. A jet tube and a dropper filled with water is connected as shown. The open end of the tube is dipped in red litmus solution. When dropper is squeezed, water enters the flask and ammonia gas dissolves in water. Hence, the pressure inside the flask decreases. Atmospheric pressure forces the red solution to enter the flask. It is ejected as a blue fountain. Ammonium hydroxide is basic, which turns red litmus solution to blue. Chemical properties of ammonia. Ammonia is a non-combustible and basic substance. It is a strong oxidizing agent and precipitates hydroxides of metals when added to the aqueous solution of their salts. Combustibility. Ammonia is neither combustible nor a supporter of combustion. Reaction of ammonia in oxygen. Pure ammonia does not burn, but in the presence of oxygen, it burns with a yellowish flame, producing nitrogen and water vapor. 4NH3 ammonia plus 3O2 oxygen gives 2N2 nitrogen plus 6H2O water. Reaction with oxygen in the presence of catalyst. The moist red litmus turns blue when the ammonia gas liberated by treating ammonium hydroxide with dry oxygen is passed into the flask before heating. This indicates the basic nature of ammonia. When ammonia is passed over heated platinum, it decomposes to give nitric oxide, which further oxidizes to acidic nitrogen dioxide. This turns blue litmus red. Basic nature. Due to the absence of ions, dry or liquid ammonia has no effect on litmus, but aqueous ammonia is a strong base due to the presence of hydroxyl ions. Hence, aqueous ammonia turns red litmus blue. NH3 ammonia reacts with water H2O, giving NH4 positive ammonium ion and OH negative hydroxyl ion. Since ammonia is a strong base, it reacts with acids to give salt and water. NH3 ammonia reacts with HCl hydrochloric acid, giving NH4Cl ammonium chloride. 2NH2O water. 2NH4OH ammonium hydroxide plus H2SO4 sulfuric acid gives NH42SO4 ammonium sulfate plus 2H2O water. Precipitation of metallic hydroxides. Aqueous ammonia precipitates hydroxides of metals when added to the aqueous solutions of their salts. These hydroxides have different color and solubility. Ferrous sulfate FeSO4 reacts with ammonium hydroxide 2NH4OH, giving ferrous hydroxide FeOH2 and ammonium sulfate NH4 2SO4. Similarly, ferric chloride, zinc sulfate, copper 2 sulfate etc. give characteristic precipitate with aqueous ammonia. Reaction with carbon dioxide. Under high pressure and temperature, carbon dioxide combines with ammonia to form urea, which is a nitrogenous fertilizer. Nitrogen content 46%. Ammonia 2NH3 combines with carbon dioxide CO2 giving NH2, CO, NH2, urea and water H2O. Reducing property. Ammonia reduces bleaching powder into calcium chloride, nitrogen and water. 3CaOCl2 calcium oxychloride reacts with 2NH3 ammonia giving calcium chloride 3CaCl2, nitrogen N2 and water 3H2O. Ammonia reduces chlorine into hydrochloric acid. 2NH3 ammonia plus 3Cl2 chlorine gives N2 nitrogen plus 6HCl hydrochloric acid. Ammonia reduces copper oxide to copper and lead oxide to lead. Dry ammonia is passed over heated copper oxide placed in a combustion tube. Ammonia reduces black copper oxide to pinkish red metallic copper. Water is collected in the U-tube. Nitrogen gas is collected in a glass jar by the downward displacement of water. Odor. Strong, pungent, irritating odor. Action on indicators. Moist red litmus to blue. Turmeric paper to brown. Colorless phenolphthalein solution to pink. Metal orange from orange to yellow with hydrogen chloride. Dense white fumes are seen when a glass rod dipped in concentrated hydrochloric acid is held near the mouth of jar containing ammonia gas with aqueous copper sulfate. When ammonia is passed through a copper sulfate solution, pale blue precipitate of copper hydroxide is formed. This turns into deep blue by the passage of excess ammonia. On passing excess ammonia, the precipitate dissolves to give a violet solution of the complex salt tetraamine copper sulfate. With Nessler's reagent. When ammonia or any ammonium compound is added to colorless Nessler's reagent, alkaline solution of potassium mercury iodide, a brown coloration is observed. This test confirms the presence of the ammonium radical NH4 positive. Uses of ammonia. Ammonia is used for the manufacture of fertilizers, nitric acid, nitrogen, sodium carbonate and other ammonium compounds. Ammonia is also used as refrigerant in ice plants and as a cleansing agent. Fertilizers. Ammonia produced is used in the manufacture of fertilizers like ammonium nitrate, ammonium sulfate, ammonium phosphate and urea. Nitric acid. Ammonia is largely used in the manufacture of nitric acid by Oswald's process. Nitrogen and ammonium compounds, nylon, rayon, plastics, dyes, etc. are made from ammonia. Ammonia is used for preparing ammonium chloride and ammonium carbonate. Sodium carbonate. It is used in the manufacture of sodium carbonate by the Solvay process. As a source of hydrogen, it is dangerous to transport liquid hydrogen in cylinders. Therefore, it is converted into liquid ammonia and transported in cylinders. The hydrogen can be recovered by decomposition of ammonia. As a cleansing agent, ammonia solution emulsifies fats and grease. It breaks down the fat and grease molecules so that they can be removed without leaving any residue. Hence, ammonia solution is used for removing grease and perspiration stains from clothes, cleaning tiles, windows, etc.